Welcome everyone, my name is Tim Burris and today I want to talk about exception handling with Faultless Execution. Faultless Execution is a library for .NET that's meant to help clean up your code from all the try catches that sort of make the act of handling an error disconnected from the code that caused the error. So we're going to jump into a sample and see what I mean. I'm going to set up a simple example and then we're going to expand on that example into more complicated real-world scenarios so that you can see what I mean. And then we'll actually jump into some actual real code where I like to use faultless execution, along with some of the ways that you can extend on it and make it do exactly what you need to do for your particular project. So here I have a very simple demo class. We are injecting a few things. One of them is this amazing web API, and the other is the logger. And we are going to move forward with writing some code. And this is how normally I would expect to write my code, handle errors, and move on. So in my do something great, I'm accepting in a state or province. So I'm going to use that. I'm going to use my API and that parameter. I'm going to say amazing web API. We're going to get some cities, and we are going to pass in our state or province. And we can see that get some cities is going to return an enumerable of cities. And then with that, once we make that API call, let's go ahead and receive those cities. With that, we'll have a method, maybe do something with cities. Very, very good code here. And we'll pass in our city enumerable, and we'll just go ahead and generate that method. Wrong key. Generate that method. So now we have the beginnings of what we would see. So here we will do stuff. So we have our call to the API to get the cities, and then we're going to do something with those cities. And since this is an API call, there's substantial risk that something could go wrong, maybe internet connection or something wrong with our request. So what I would expect to do is just go ahead and wrap this guy in a try catch, and if we get an error, we would log that error, and we'll just log that, and you failed me. This is typical code, and then return, because maybe down here we're going to do some other things. In this way, if we get an error in the API or in the do something with the cities, then we will catch our exception and log the error and return. Of course, this code is very simple, but let's see how that would look with faultless execution, and then we'll build on that moving forward. So we're going to create another method of this, and we'll call this one do something great faultless, and we will still accept in our state or province. And now, instead of just writing our function, our API call, and wrapping in a try catch, what we are going to do is we're going to go ahead and inject in our Faultless Execution Service. So Faultless Execution, Abstractions, Faultless Service. So I've already wired this up with dependency injection, but you know, that's typical .NET stuff, but you don't have to. Obviously, if you're not using dependency injection, you could just new up a Faultless Execution Service. But for this purpose, we are going to go ahead and inject our service and show how we would use this in a real world. So here, when I get ready to make my API call, I know that that's going to be kind of a risky call, something that has a decent amount of opportunity to fail. So I'll start with my faultless execution, and I will say try execute, and I'm going to pass in a delegate of what code I want it to try. And in this case, it'll be to call the amazing web API, get some cities, pass in our state or province, just like we did before. and we want to get that result back into a variable. And what's going to happen here is faultless execution is not going to do too much. All it's going to do is invoke this code, but it's going to wrap it in a try catch. And what it's going to return to us will be a result with our cities on it. And off of that result, we'll be able to test to see whether or not an error occurred. So after our call is complete, we'll check our result and say, were you successful? And if you are successful, then we will do something with the cities, and off of our result will be our return value, which, just using .NET generics, nothing super magical here. It knows that that's an enumerable of cities because that's what our delegate says we're returning. And that's it. Inside of Faultless, if you're using dependency injection and you're using Microsoft extensions logging, it'll actually log the error message for you. So you don't actually have to do anything else. This will run the code, and if everything works, return our success, and then we will move on with processing the cities. Now, if we were not using Microsoft extension logging, which is fine, then you could just in your else go ahead and write your log message. But since we we really don't need to do anything else. Now, when we look at this code and we look at the original code, there's not a bunch of improvement here. The value is not in the most simple cases, but there are also some extensions in the library that could make some of this a little more readable, kind of taking a fluent style. So we have our try execute. After that, we could do on exception, and we could choose, well, what do we want to do when there's an exception? And it'll pass us in the result that'll tell us, what the error was. And we could say, on exception, I want you to log error. Again, we don't need to log the errors because Faultless will log it itself, but let's say that we wanted to log it separately, we want to log a different message, or we want to do something other than log it. Maybe we need to do something different. We could just log error, and we could pass in our exception and say you failed. And then similarly, we could also use on success. I actually don't use these extension methods that much. I think on the surface, I believe they would be very useful, but I just don't find myself actually using them very much. I almost always do my checks, like is result successful, and then have my if and else there. But you do have the option to do this. So here we could say do something with the cities, and we could pass in our return value, which would be our list of cities. So we could kind of go with a fluent style here, where we try to run our execute. If it fails, do something, and if it succeeds, do something else. Then we wouldn't even need this block of code. Some other things that I guess are little things. They're not amazing, but do provide some kind of coolness. There is a retry. So maybe you wanted to retry, since this is an API call. Maybe you wanted to retry 3 times, for example. So if we get a failure, then it'll keep retrying 3 times. There's a retry once, so we could just retry 1 time, and there's some kind of conditional, like retry if, and then maybe you check the type of exception and retry. That being said, those are okay little extension methods, but if you want real retry logic, robust retry logic, you should check out Poly. Poly is a library built all around that kind of concept of retrying. So this might get you, a few simple things, but if you want some robust retry logic, that's not the purpose of faultless execution. So, but we're going to go ahead and just kill these and get this back to the basic. We have our call, and if it's successful, then we'll do something with the cities. Now, when we look at these two blocks of code, they're not that much different. This really is not, Faultless is not providing you a bunch of clean code here. I do like it a little more because it kind of reads a little bit better, self-documenting about what the goal is. But, it's kind of the same. But what realistically happens is we have this try catch here. This is great, but we're catching two different things. And likely, if we get an error coming from our API, we want to do something differently than if we get an error coming from our do something with cities. Maybe we want to log the message differently. We probably want to log the state or province. So what I would see happen, what I would actually do here is I would typically come in, all right, well, if my web API fails, I actually want to handle that differently. So I'm going to write another try catch around this just so that I can know the difference between an error in my web API versus an error doing something there. So I'll create a second try catch, and in here I'll do my log error, and I'll provide some additional information this time. And we'll say failed getting data for, and we'll just say state. We'll do a structured log here and state or province. So this way, if we get an error from an API, our log message will actually tell us what we were trying to do with the API. The actual input variable that we were using. But then the next thing is, well, of course, I need to actually send the exception in. The next thing is it's unhappy because now we've changed the scope and cities need to be moved out. Of course, with refactoring, this is not rocket science here. You can very easily extract this out and move this guy up, make him cities right there, and then return if we have an error there. So now we have our cities. We have our two try catches. The code is getting a little more complicated. Still not the end of the world, but you can imagine compounding this with multiple checks. So now this try catch structure, this flow is a bit more difficult to read. However, the same thing using Faultless would look like this. We still have our first call, and then on this guy, we could simply just try to execute this one. And again, since logging happens automatically, we don't need to do anything extra. Up here, if we wanted to include the state, we could just do on exception, like we were looking at just a moment ago, and say logger. In fact, I will just take this code right here, and we'll just drop it in. And of course, the exception here will change a little bit. This would be off of our input value there. So now we get a separate exception message, a structured log for that guy. And when we make a call to do something with cities, it'll also be wrapped in a try catch. And if there's an error, then it'll get logged. So when I look at these two blocks of code, without much changing, just the idea that we need to trap API exceptions separate from the other exceptions that might occur, now I start to see some code that's a little easier to read for me, because when I look at this self-documenting, telling me exactly what I expect to happen, what I expect to happen when there's an error, and I'm also describing that I know that this is sort of a risky call, and I'm going to go ahead and describe that I know there's a possibility that this is going to fail, and I want you to catch the error. When I look at this code, of course, you have this try catch. It looks like it's catching everything, but it's actually not. It's only catching the ones that didn't get called here. And so I find this to be a bit cleaner solution. And this is really great for all the one-off, all the places in code that you should be putting a try catch, logging there, and moving on. Now let's look at some real-world code where I've used faultless execution, but more than just the basic faultless execution, we're going to look at how we can build on this faultless execution to provide things like toast messages. Here's an example of a view model where I need to go and load data from a bunch of different sources, and I'm using faultless execution each time. I could wrap all this in one big try catch because all I'm doing is returning false if it fails, but I feel like this code self-documents that When I make this call to the company service, I'm saying there's kind of a decent chance that we might have an issue here. So I'm going to go ahead and wrap it in a try catch, and if we fail, we'll go ahead and bail, and we'll do that for all of these guys. And then those would just log the errors to the logger. But what if we want to tell the user when something errored? If you're familiar with the MVVM pattern, then you'll know about relay commands. And relay commands are a way that the view or the user interface will communicate with the behind the scenes view model for things like a button click or any action that the user has performed to tell the view model to do something. In this Blazor server application, we have some relay commands. For example, right here we have an add contact command, and anytime the user clicks an add contact button, or really we don't care how add contact gets invoked, but when they do invoke this add contact, we are going to ultimately call this add contact async, which is going to show a modal and do some great stuff. But right here before that, we're going to wrap this entire thing in a faultless execution implementation that uses toast. So if you're familiar with toast, or if you're not familiar with toast are the little messages that'll come up like in the corner of your browser or the corner of your application to tell you that either something was successful. Maybe a green toast message comes up and says saved successful, or an info box comes up and says you need to refresh your screen, or what have you. So those are toast messages, and what we're saying is the user has invoked a command. They have asked to add a contact, and we're going to wrap it in this execution service and say, if any unexpected error handles, we want this guy to handle it. Well, what is this guy going to do? What is he doing? So let's go check him out. First, we'll check out his interface, and we can see that all it's doing is deriving itself from the faultless execution library that we're looking at, the base one. It's not providing any additional methods, but it provides the same methods that this guy provides. So then we'll look at the actual implementation, and we'll see there's not a ton that has to happen here either. We have our constructor. In our constructor, we're going to go ahead and inject in our Blazor toast service. So this is a third-party library for doing toast messages in Blazor. And we're going to inject our logger in. We're going to, of course, store those. And we're going to tell our faultless execution, which I should have shown first. We are deriving from the base faultless execution service and implementing our toast service. Since we're deriving from this, we're going to tell faultless, hey, don't log the messages. I'm going to log them myself, so when you get an error, that's cool, just don't log it. Because we don't want to log showing up twice if we are going to handle it. And then all we're going to do is override on exception. We could override on success and do things, but for this purpose, what we want is if an error occurs, we want to show a toast message for to the user. So we override our on exception. We just call the base, even though it's pretty much not implemented. It's really not for us to make any assumptions about whether or not there's code in there. So we should assume that it needs to be called. So we'll call that. We will log the message ourselves. And a lot of times when I log messages that I know the user has seen, I like to include a message. So when I'm reviewing the logs, I know, like, was this a behind the scenes message and the user doesn't really know what happened? Or should I have expected the user to have seen some kind of message? So here I am going to just add the message that we toasted them, and then I'm just going to use my toast service and give them a very generic message that an error occurred whatever. Also, I used string interpolation and didn't interpolate anything. Good job. So now that we looked at this faultless, anytime we have something coming from the user, at some kind of action that the user is performing, all we have to do is wrap it in our faultless execution service, and we'll know that if any error occurs in this code, they will get toasted, and of course it'll get logged, and our application will not crash. Because depending on your technology, whether it's WPF, Xamarin.Forms, Blazor, what happens when an error occurs in a relay command can be different. And this way we'll ensure that no unhandled exception gets through. And if we decide to completely change our toast service, then none of this code has to change. We can simply go and change our toast implementation, swap out our Blazor toast service with some other type of service. And in fact, I guess if we wanted to make this even more generic, we could not call this toast faultless service. We could just make this maybe a user notification service, and then the default implementation would be toast. And then that would even abstract it a little bit more, so that if we decided we wanted to show an old school alert box, then we could do that instead of showing a toast. And that would allow this code to be completely agnostic to, well, I don't care how you tell the user, just tell them. But for now, toast. And if you were in WPF and you wanted to do a message box, I do have an example of that as well. Super simple, and the same concept. We have our show message box faultless execution service, derives from the base faultless execution service, and on exception, it's simply going to show the old school Windows message box. And then last but not least, for these user notifications, we'll look at one for Xamarin.Forms. And this one does a bit more work. So we have our user notice faultless execution service. It's going to derive from Faultless. It implements its own interface. It receives a third-party package for showing user dialogues in Xamarin.Forms. And on exception, it's actually going to do a few things a little bit differently. We're using Plural. If you're not familiar with Plural, you should definitely check it out if you are making calls to REST APIs and you're building your URLs by hand. It's pretty awesome, but not the point of this video. But if we get an HTTP exception, then we're going to do some checking on that exception. And if it was an unauthorized for this particular application, then we're going to give them an alert that says your session has expired. You don't have access. Try logging in again. And everywhere we use this service, all those relay commands that we wrap in this service will automatically have this logic. And we can just tweak it as needed. Of course, if the error was not an unauthorized, we're going to do a little bit of other checking, and then we're going to log some information that's pertinent to make an HTTP request, like getting the full response and logging it. And then if all else fails, if it was not an HTTP exception, we're just simply going to log the messages. Well, actually, this is just a last failsafe. If we have errors, just checking out the exceptions, then we're just going to log the messages. But if it's not an HTTP exception, then it'll just go through and exit out of this loop, and we'll get a generic alert about an unexpected error occurring. Look, copy and paste from one project, another beautiful string interpolation with no interpolation. Now next, let's look at how we can expand faultless exception for things other than just showing the user an error message, letting them know that bad things happened. Here we are in a web API, a REST API for a basic CRUD of a user. So you can get a list of users, you can get a single user by his ID, you can update a user, you can delete a user, all the basics that you would expect for the CRUD of an entity. But in this, you can see that we're using faultless execution to go and do the things in our services. So when we want to get a list of users, we'll use our user service. We'll go get them, but we're wrapping it in this faultless execution service. But this implementation is a little bit different than just the base implementation. This one's built for MVC or for Web API, and instead of just try catching and logging the error, what it's actually going to do is return our action result codes. So if we ask for a list of users and we call our try execute, then we can see from the comments here, if it's successful, then it's going to return an OK object result, which would be a status code 200, which is what we want. But if it was unsuccessful, then it's going to return a bad object request, which would be a 400. Now, we can get into a whole bunch of conversation. Should it be a 400 or a 500 for the errors? Well, you can write it how you want. For this particular implementation, we return the errors as 400 because, I mean, clearly the error is never on our side, so we're not going to return a 500. We know that any error that comes when getting this list of users must be the fault of the caller. But we won't get too far in this debate of 400 versus 500 error. But you could code it how you wanted. You could absolutely make your adjustments, create your own implementation. But the point being, it's going to handle doing these, executing these functions and returning the appropriate codes. So for a list, we return an object result. For a single record, if it'll go out and get that record, and then there's an extension method to say, well, you went out and got the user from the service, but it might have returned null, which would indicate that user doesn't exist. So there's another extension method here to say, well, if you didn't throw an error, if everything was successful, but we didn't get an actual user back, it was null, then what we want to return is a not found. We want to return a 404 from our API because that's the correct thing to do if they pass in an ID that doesn't match up with someone. The similar things for the update user. So when we call update user, our try execute will return a no content if there was an error, if there was no error, I should say, and of course still a 400 if there was an error. I mean, here we're really getting into some of the advanced scenarios of what you can do with faultless execution if you want to use some of the advanced packages out there, or if you wanted to write your own on top of it. But jumping back to the more simple uses of it, even just in the everyday use, I think you can get some value out of handling your exceptions in a way that they're not quite so verbose, and do a little more to self-describe what the intended result is. As always, thank you for taking time to hang with me. Have a wonderful rest of your day.